So this problem says, find the nth term of the arithmetic sequence a sub n whose initial term is a1 and the common difference is given. What is the 52nd term? So with this problem here, they give us all the information we need. They give us the a1 equals 5 and d equals -3. And if we remember the formula, which is a sub n equals a1 plus d to the n minus 1, we can find the nth term very easily here. Okay, so all we're going to do is just plug this in. So what I mean by that is we have an an, and that's coming from here, and that equals a1, and a1 is 5, gives it to us. So we put a 5 there, and then it says plus d. Okay, so this is our d here. So instead of a plus, I'm going to put just a -3, and then n minus 1 times n minus 1. So I'm going to write n minus 1 there. And now I'm going to clean this up a little, of course, for sure. So this is really going to be 5 minus 3n plus 3. And that equals, and this is our nth term here that we're finding. So this is going to be -3n minus 8, or plus 8, excuse me. Yeah, so there it is. Now again, notice they said the d was -3. That means it's going down by 3 every time. So that's why we see this -3 here. You can think of it like a negative slope as well. So my a sub n is this term here. Now what's easy about this now is all I'm looking for is a 52. So that means I'm just going to plug in 52 for n. Now remember, that's what that subscript means down there. That number means that's what I'm plugging in for my n. It's just that simple. So don't make it any more complicated than it is with those. So now 3 times 52 plus 8 is 164. So there's our answers for this one. So first off, the first answer would have been an equals -3n plus 8. And the second answer is 164. So there's our two answers for this one here. Now let's try this problem below here. It says, find the indicated term of the arithmetic sequence. 70th term of 2, 5 halves, 3, 7 halves, and so on. I should have a ... here. So it continues. So again, remember, how do we find d? We just take the a sub n term. So this term right here, we could take and subtract that term from it. And we could also do it from the first two if we want. I could take this one here and this one here and say, hey, what's 5 halves minus 2? So that's how we're going to do this. That's it. And that's how we find d. So I'm just going to say d equals 5 halves minus 2. I got to put it over 1 here. And times by 2 times by 2. Like denominators, right, guys? So 5 halves minus 4 halves. So that's going to be 1/2. And if we think about this here, 3 is really 6 halves. 2 is really 4 halves. So that'd be 4 halves, 5 halves, 6 halves, 7 halves. So it makes sense if I look at the pattern and say, hey, if I make the same denominators for those, then I can see the pattern. And that makes it pretty easy too. So the difference is 1/2. And if you didn't notice, I already have a1 too. a1 is 2. It's the first term. Remember? a1, a2, a3, a4, ... Don't forget. So then, now we get, for our final answer, we know the handy dandy formula from above here, right up here. So we're just going to use that now. So an equals a1 is 2 plus we have 1/2 for the d there, and that's going to be n minus 1. Now I'm going to just multiply this out and simplify, and I get a sub n equals 3 over 2 plus 1/2 n. Now I didn't need this for my answer here, so just be careful, but I wanted to show you where I ended up with, what I ended up with for this algebra. Now what we're going to do is we're going to find the 70th term. So I'm trying to find a 70. And that simply means I'm plugging in 70 for n. Oops. So we get 3 halves plus 70 halves. So that equals 73 halves. So there's our actual answer for this problem. So that's another way I can look at it. So the first one, they gave me D. For the second one, we had to find D. Okay, those are just really the same type of problems, just I have to find different pieces of information, but it always comes back to that formula. Now we have a third type that we can see that uses this same information. So let's take a look at that now. So this problem says, find the indicated term of the arithmetic sequence. Give a recursive and explicit formula for the sequence. So this is giving us a little bit more, or telling us to do a little more here, but not much more. Once we find the indicated term, or we're going to find the explicit formula first, and from there we can find the recursive formula afterwards. So anyways, taking a look at this one here, we know the 15th term is 0. So the indicator here, they told us it was arithmetic, which tells us that I'm going to have this common number. I'm going to go, 5 plus 2, or whatever it is for each term here. So I know the 15th term. So if I go A1, ... A15, ... A40. That's the idea here. So the 15th term is 0, and the 50th term, or 40th term, is negative 50. So there we go. That's what we know. So how many terms from 15 to 40? So that would be a 25 term difference there. So there would be 25 terms there. So what I can do here is I could just take this here and go, okay, what's 50, negative 50 minus 0? So it's going to be negative 50. And then I can divide that by 25, because it's 25 terms to get to 40 from 15. So that's what we're going to do here. So that would actually be negative 2. So I'd go negative 50 minus 0, and that would be negative 50. And then from there, because I would just be finding a difference from 0 to 50, negative 50, excuse me. And then we would say, okay, I would divide that by 25, because there's 25 terms between 15 and 40. And that's why we're splitting that up. And it has to be the same because it's arithmetic. So it'd be a negative 2. They have to be even for each of those, I should say. So it'd be negative 2 for my difference. So now that we have that difference, we're back to where we were before. I don't have the A1 term, but now I can find the A1 term. So to get to 15 to 1, so that'd be 14, 13, ... 3, 2, 1. That's actually going to be 14 terms there that we're going to have between, going back to A1. So like I said, that will be 14 terms. So then I'm going to go negative 2 14 times back. So that means I would be subtracting negative 2, which is really, if I go forward, I'm subtracting negative 2. If I go the other direction, I'm adding 2. Because it's coming from a bigger number and it's getting smaller because that's a negative 2. Very weird idea, but that's kind of the sense of it all. Now, it wouldn't be negative 2 from A15 and A1. It would just be from the previous term, but I just wanted you to think about the idea of a negative 2, positive 2 idea here. So the common difference, since it's decreasing every time, that's going to be a negative 2. when I'm going forward. But if I'm going backwards, it's really like I'm adding 2. So just be careful with that. So it's really adding 2 14 times. So it would be 28. And we can always check that too. So the A1 should be 28. And this made it kind of easy because since I'm going back 14 and I'm adding the 2 instead of negating it, that's going to be 14 times, or 28, 14 times 2, which is 28. So I'm going to add 28 to 0 here. And that's really what I did. So then I get A1 is 28. So now I have everything I need for my handy dandy formula. You remember the formula? There it is. So that's the one we're going to use. So that gives us AN equals A1 plus, and I'm just writing out the formula again, DN minus 1. So then my AN is equal to 28 plus D is actually -2, so I'm just going to put the negative there, and N minus 1. So when I clean all this up, I get AN equals, and that's going to be 2N plus 2. So 30 minus 2N. And then from there, I can actually find the, when was I supposed to find a term here? I didn't put a term down there. So do you guys want to find a term? We'll say find the 10th term. Okay, we'll say that. Find the 10th term. Oops. There we go. We're just going to find the 10th term. So then all I have to do is plug in a 10 there. So that's going to be 30 minus 2 times 10. That's going to be 20. So my A10 is going to be 10. Oh, nice. Okay, so anyway, so there's that piece. Sorry I had to add that in there. That's okay, though. No big deal. And then it says the recursive and explicit formula for the sequence. So now what I'm going to write out is my one answer here. And I'm going to write this one in red. So this is my first one. 30 minus 2n, n equals 1 to infinity. This is my first explicit formula. Now for the other one, I have to write a few of my terms out to kind of get the idea of what that looks like. Or go way back. So remember this? This is actually the explicit form here. So if I take a look at, we can even take this first one here. Notice this one right here. That one there says A1 equals A, and AN equals AN minus 1 plus D. So we could actually just use this to get the recursive formula for this one. So then that would be for us, and I'll flip back so you can see it. So my A1 is A. So that would be, my first one would be, remember A1? A1 was 28. So we would say, oops, A1 equals 28, and then we would say AN equals, and let's go back to what that said. That says A1, AN minus 1 plus D. So AN minus 1 plus, and what was D? Oops, I would say D was -2. So this here would be the recursive formula of any arithmetic sequence. So again, that D would change here and my A1 would change, but the rest of the formula would stay consistent. So my explicit formula then, which is here, that's going to be this one here. And my recursive would be here. All right, there it is.